Hi students, today we are discussing the remaining part of module 5, performance characteristics of measuring devices. This is also the fifth module part of ME 312 Metrology and Instrumentation. I am Radhakrishnan, Assistant Professor, Department of Mechanical Engineering, Tokach Institute of Science and Technology, Cochin. Performance characteristics of measuring instruments. All instrumentation systems are characterized by the system characteristics or system response. The knowledge of performance characteristics or system response of an instrument is essential for the selection of most suitable instrument for a specific measuring jobs. It consists of two basic characteristics such as static and dynamic. If the instrument is required to measure a condition that is not varying with the time, it is called static characteristics. And dynamic, whereas dynamic characteristics means it is a time varying process variable measurements. Let us discuss the details of these two. Static characteristics. Accuracy, we might have studied in the first module itself. Accuracy, it is the degree of closeness of measurements to a expected value or the standard value or a true value. Highly accurate instrument produces low errors because the difference between the true value and the measured value will be very less. Precision, suppose if you are taking 5 or 6 measurements on the same part, the successive readings that you have taken have a closeness or a mutual agreement between the readings. A measure of consistency or repeatability of the measurement. Repeatability, closeness of agreement among a number of consecutive measurements of the output for the same value of input under the same operating conditions. This we are doing in the laboratory also. Suppose if you are using a dial indicator, first we are setting for a particular value and we are checking whether it is giving same reading, same zero setting at 5 or 6 times we are checking. So if it is capable of giving the same reading or zero setting, then it is said to be have a repeatability. Reproducibility means the closeness of agreement among a number of consecutive measurements of the output for the same value of input under same operating conditions with different operator, different time over a period of time. It is called reproducibility. Suppose you are getting a reading for a particular value today, then after that, over a long period of time, if the instrument is again capable of giving the same set of readings, then the instrument is said to be having reproducibility. Sensitivity, it is a change in the output per change in the input. High sensitivity means small change in the input, the equipment or instrument will give the large output. That is sensitivity. More sensitivity means more change in the output per change in the input. Resolution. Resolution is the smallest change that can be detected by a sensor. It is also defined as the minimum value of the input required to cause an appreciable change or an increment in the output. Suppose if you are taking an ammeter, its one division is 0.1, small graduation is value is 0.1 amps, means that is the smallest, the least possible measurement that we can take with the help with that instrument. Micrometer is 0.01 mm least count or resolution. That means we cannot go below 0.01 mm. That is the least measurement with which we can take a measurement is 0.01 mm. Any instrument, it will have a resolution that is the smallest change that we can detected by this instrument. Threshold. This is a minimum value below which no output can be appeared. That means, suppose some instruments, you can see that some pressure gauge or something in instrument that will not, that is minimum value we have to give. Suppose 0 to 140 speedometer is there. Suppose for a change of the needle, at least 5 km per hour this vehicle should run. That is minimum value, that minimum value below which no output. That means 5 km speed, then the needle will start. There will not be any movement for 1 km, 2 km, 3 km, 4 km, etc. That means 5 km is the minimum value below which, that means 4, 3, 2, 1, there is no response. No output can be appeared. That is the minimum value of below which no output can be delivered. That is called threshold. Drift. Drift means the variation of output for a given input over a period of time. Many instruments, suppose if you are giving some input values and you are taking the output values. Suppose after 3 or 4 months, the same instrument under same conditions, if you give the same input values, it will not give the input values which you got months back. For example, if you take a pressure gauge, suppose we are putting 1 bar, 2 bar, 3 bar, 5 bar pressure and take the output. After 3 or 4 months, suppose if you are taking the same values, input values, that is 1, 2, 3, 4, 5 bar, etc., you will not get the same values as you got before. So that means the instrument which will have got some kind of drift, it is called, that is the output values will not be same as previous values for a given input. That is called drift. Error. The deviation of the true value from the desired value, that is error, is, suppose if you are measuring a diameter of a component of having 10 meter standard size, 10 mm standard size, diameter of 10 mm standard, that is standard cylinder. Then if you keep in between the jaws of the, or measuring anvils of the micrometer, you'll be getting 10.01 or something, or 9.99 maybe. So the measured value is 9.99 and true value is 10 mm. Actual value is 10 mm actually. That is a standard value because standard cylinder we have taken. So we are getting the error of the measurement. Saturation or dead zone. while we are any instrument, if you take a point is there when output will no longer increase for the increased input. Suppose a pressure gauge of 0 to 100 bar. So after 90 or 95 or something, then if you are giving 96 bar, there will not be any change. 90, 100 bar, that will not be any change because that area is dead. So that is why the useful range is that we can calibrate for which area, up to what point for the increasing or changing input, the instrument shows output. So dead zone will be there in any instrument. A point is reached when the output will no longer increase for the increased input, giving rise to non-linear relationship. All other points, input is changed, output will be changed. Again, input is increased, output will be increased. So it is a linear relationship. But in dead zone, you will not get such kind of linear relationship. That is why it is a non-linear relationship. So saturation or dead zone is the largest range of values of a measured variable to which the instrument does not respond. That is saturation or dead zone. Noise. Random fluctuations in the output signal. That is an unwanted thing actually. Mechanical vibrations and electromagnetic phase from power supply. Then the temperature. So many things are there, external factors are there. That will give its own signals to the output. So that is unwanted things. That is why it is called noise. Backlash. It is the lost motion of free play of mechanical elements such as gears, links, threads, etc. That means the gears are engaged exactly the teeth of one gear is exactly inserting between the other teeth, mating here. Suppose if there is any worn out, what will happen is one gear will rotate, then other gear will not rotate because it will not give motion because it is worn out. When it will not make a contact because for a part of this rotation it will not make any contact. That is why it is called backlash. Similarly, thread. Suppose thread is worn out means it will rotate, thread will rotate, but the anvil will not advance or lead will not be there. That is why it is called backlash error. It's a static characteristic. Range is a term used in all instruments. Suppose 0 to 100 amps ammeter, 0 to 500 voltmeter, 0 to 200 mm vernier caliper. That means the minimum and maximum. That is the minimum and maximum values for which the instrument is designed to measure. That is range. In case of some temperature measuring instruments, it will be minus 40 degree to 500 degrees centigrade. So minus 40 is the minimum value and 500 degree is the maximum value. So that is a range will be the minimum and maximum values. So it is expressed as minus 40 to 500 degrees centigrade, 0 to 100 mm, 0 to 500 volt, like that it is expressed. Span. If you take the range, suppose if you are taking minus 40 to 500 degrees centigrade means, what is the span now? Span means you find the difference between these two, maximum and minimum. In case of the temperature of minus 40 degrees centigrade to 500 degrees centigrade, span is 540. 0 to 100 amps means its range is 100 minus 0, that is 100. 0 to 500 volt, that is 500 to 0, that is 500 minus 0, 500. So span is 500. If you take the difference, range means the minimum and maximum values only. If you take the difference between the maximum and minimum, you will get the span. Bias, the constant error which exists over the full range of measurement, that is biased error. Suppose a micrometer, if both anvils is coincided, actually we expect it should read 0. Suppose if there is an error of 2 divisions, 0.02 mm plus 0.02 mm, what will happen is, suppose if you are measuring a exactly 5 mm diameter component, so the instrument will read 5.02 because already 0.02 mm is the zero error reading, that is biased reading, already is there. Suppose if you are taking 10 mm, it will show 10.02. If you are taking 12 mm, 12.02. So the biased reading is always reflected over the full range of the measurement. Suppose a ammeter, it always shows a 0.1 amps error. Suppose no current is there, but it shows 0.1 amps. Suppose if you are measuring 2 amps means it will show 2.1 only because this 0.1 is already there in the instrument as bias. That is why it shows bias error. Static characteristics, again which is continued. The calibration, this already we discussed in the metrology side. Calibration means it is a process of checking dimensions of a gauge or accuracy of a measuring instrument by comparing it to an instrument or gauge that has been certified as standard of non-accuracy. Suppose in our metrology lab we are using the standard as gauge blocks, then we are calibrating micrometer, vernier, dial indicator, etc. So the process, that is, we are comparing, we are checking the accuracy of the micrometer, vernier and dial indicator against a standard, that is a certified standard, that is a calibrated gauge blocks. That is, the process is called calibration. Hysterisis. So, before explaining hysteresis, I will tell you an example. Suppose if you take the pressure gauge, then suppose it is a 0 to 10 bar pressure gauge. I am keeping 1 bar first. So you are getting a reading as, any reading you are getting, you are noted down. Then 2 bar, you will be getting 2 bar. Then 3 bar, again the output will be there for the 3 bar. Like that up to 10 bar I am calibrating. After that, when it is reached the full span, then I am unloading each weight, that is 1 bar is reduced, then 9 bar. That is, after reaching the loading, I am unloading the weights, dead weights, then 9, then 8. Then also we can note down the output values. The input as well as input is same, but the output values varies for the loading and unloading conditions. This is, you can take the same case for the spring balance also. Loading and unloading, there will be some changes. Suppose if you take a digital scale, weighing scale also, if you take 1 kg, 2 kg, 3 kg, 4 kg, 5 kg, after that if you reach 10, then you are reducing the weights by 1, that is unloading. You can take the readings, the both loading and unloading readings will not be the same. That is, so there will be an error. This error, the loading graph you can put. Maximum difference in the output when this value is approached from the opposite direction, that is loading and unloading. See, loading graph is there, unloading graph is there. So there will be a maximum difference will be there in between. We are calculating that. For a particular input, there will be a maximum variation in the output, loading and unloading. That is called hysteresis. It is clear from the figure shown below also. Linearity. Some instrument shows always linear relationship. When the input is changed, output is changed, and again input is changed, output is that the relationship will be linear. Then linearity, you can say we can take the slope of the curve, you will get the constant of that linearity also. Some instruments will not have any kind of linearity. So non-linearity, that is output that is not proportional to the input over its entire range. The graph will be some kind of a curve. So that's all about the static characteristics. Then we can see dynamic characteristics. Dynamic characteristics means it's a time variant characteristics of the instrument. So response time, the time taken by a sensor to approach its true output when subject to a step input. That means, suppose we are giving one bar pressure into a transducer or a pressure transducer or something. So it will start, it will reading, it will vary its output, but we have to wait for some time to reach a steady value. Again we are changing the input, again we have to get the true indicated or output value of the measurement after some time. So the time it takes to approach its true output, it is called response time. Time constant. Time constant is a value, that is a time taken by the system to reach 63.2% of its final output signal. So final output value will be there. For any input there will be a final output value, but the time taken to reach 63.2% of its output value, that is called time constant. This time should be very, very less for a higher response instruments. Suppose the response is more, means it will reach quickly the 63.2%. Rise time, the time taken to reach 90% of the full response. Next is setting time. Time taken by a sensor to be within the close range of its steady state value. That is, when we are measuring something, we are changing the input and accordingly the output will be changing. But before coming to the output, it will be coming to the close of this output value. That value is called setting time. Then frequency response, the ratio of output to input change with the sinusoidal input frequency, that is output to input value with sinusoidal input frequency. In terms of input frequency we are taking, it is called frequency response. Measuring lag, the delay in the response of the measuring system to changes in the measured quantity. That means, that is two types of that. That is a delay. There is a time delay is there in the response of measuring system. When we are giving an input, the instrument will not move at all. So there will be some kind of lag. That is, one is a retardation type. Response of the measuring system begins immediately after the change is measured quantitative. That is retardation type. Response of the measuring system begins immediately after the change is occurred. That is retardation type. Time delay lag is there. That is, response of the measurement system begins after a dead time. Some time is there, 1 or 2 seconds or 0.1 seconds, like that. Then only it will start responding. That's a time delay lag. Fidelity. Fidelity means the degree to which a measurement system is capable of reproducing the changes faithfully without an error or a dynamic error. That is, we are using fidelity meters, fiducial indicator, fidelity meter, because this measurement force, contact force, everything is a factor. Suppose if we are giving more force in micrometer, we are using a ratchet stop to know in order to avoid the fidelity error, because irrespective of the operator, irrespective of the person, irrespective of the component, the ratchet stop gives the constant measuring force over number of readings. So the dynamic error due to fidelity can be avoided. In some instruments there will be a fidelity meter, that will be a sensing element. When the component makes the contact with the measuring anvil, then it starts deflecting. Then the operator knows that we have made sufficient contact pressure over the component. So otherwise, if it is not there, we are applying, each and every person apply his own force, and each and every person will get different readings for the same input. The fidelity error will be there. So the fidelity means the degree to which the measurement system is capable of reproducing the changes faithfully without any dynamic error. That's all. Thank you for listening. Thank you.